Alright, welcome to this new tutorial. In this video, I'm going to introduce and describe one of the most important topics of statics, which governs all relations and interactions among the mechanical structures and components in mechanical engineering and civil engineering. The topic of this tutorial is moment. Like usual, first of all, I'm starting with the definition of the topic. When a body is subjected to a force besides its tendency to move along the line of action of the force it tends to rotate about an axis. This tendency to rotate is called moment or torque. So this definition highlights some important points. First of all, that force is a vector because it has a direction along the line of action. And the tendency to rotate, which is called moment or torque. Imagine when you're at home and you want to relocate a sofa, you push it toward the location you want to put it. But sometimes the sofa doesn't move along the direction you tend to move it. Then you adjust your hands or your standing position to push it again. That tendency to rotate is called moment because the force you exert on the sofa has a certain distance with the axis of rotation, which can go through the point of gravity of the sofa, and it makes sofa rotate. In a rigid body like this, if O is the point that the axis of rotation passes through and force like F is exerted, the rotation occurs when there is non-zero distance between the point O and the line of action. And since this is a rigid body, the principle of transmissibility allows us to remain the magnitude of force along the line of action. So this non-zero distance causes rotation about the axis around the point O. This axis is along the z direction, which we cannot see on the 2D plane because this axis is perpendicular to the screen. Now we are on 2D xy directions. So the moment can be expressed mathematically as the interplay between the vector of force and the perpendicular distance between the line of action and the point through which the axis of rotation goes. This is the general formula of moment. Two important points must be mentioned. First, D is a perpendicular distance, and the second one, moment is a vector quantity. Because this is the result of the product between a force vector and a scalar quantity d. In other words, we can say d acts as a coefficient that is multiplied by the force vector. To clarify the vector nature of moment, let's consider this round body. If this is the point O, and if this dashed line is the axis of rotation along z direction, and if this is the F, and distance d, this will be the direction of rotation, but the moment vector is here. This is the moment vector which aligns the axis of rotation. In most of the resources, the convention states that when the rotation is counterclockwise, the moment must be considered positive, and when it is clockwise, the moment is negative. But it is optional. It's up to you to follow which of the conventions, but remember, if you pick one of the conventions up, you have to follow it till the end. Because one of the most critical mistakes that students always make and they struggle with is the sign of the moment. The value might be correct, but a wrong sign can lead to an incorrect answer. So the convention is very important, And in this tutorial and the upcoming problems, we will follow the counterclockwise positive sign. Another point I would like to highlight is that in some resources, the formula of moment is expressed as vector components. So if this is the rigid body, if this is the point O, and this is the force vector, here distance is stated as the position vector. R. So R is a vector. It doesn't depend on any specific point on the force vector, but it creates an angle with the force vector like alpha, and this alpha is a link between the position vector and distance d. So if I want to write the vector expression of the moment, it will be r cross f. Since all of the components of this expression are vector quantities, so the order is important. So I cannot write f cross r. The order is very important. But also, I can relate r to d based on the geometric calculations, where d is equal to r times the sine of alpha. So I can substitute this expression in the initial formula that I wrote before and write f times d is equal to f times r times the sine of alpha. Of course, this vector expression is not common because it's a bit complex and sometimes it might be confusing. But I just mentioned it to have it in mind, and we will use the general expression here. So in this tutorial, I introduced and described the definition of moment, its formula, its concept, and in the upcoming tutorials, we will focus in more details on the concept of moment, and we will have very fruitful exercises.